Hi. We are live.
Hello everyone. People have been started joining. Hi guys. Hello everyone. How you all doing? Let me get my mic up.
Good morning, guys. Good afternoon and good evening for some people. Some lucky unlucky people. Yeah, including me.
Hi everyone, welcome. It's my good afternoon. Not, it's kind of afternoon, 12 p.m. Hello
Good for
everyone. Hello. Hello. Welcome guys, welcome in the workshop series, Build and Chill. And it's the second episode that we're gonna perform today. And I really wish, and yeah, I actually see like law. We had a lot of submissions for the workshop one task that we last week we released the task one on the forum, and those who have not finished the task one, uh, it's not yet late. So yeah, start doing from this workshop and get a chance to win from a $1,000 worth of maize from the prize pool.
Yep, it's not too late to start, guys.
Yeah, it has been just like one workshop that we have conducted yet, and yeah, it will be good like if you stay here till the end and check out our whole workshop, so which will be really would be helpful to finish your task easily. And yeah, we also have like recording after that you can watch in YouTube, so feel free to go there and check out. And yeah, let's see.
Awesome. All right, guys. In this workshop, we're gonna see the utilization and how we can build with LazAI API. And this is the second episode of Build and Chill series. And it's not just gonna chilling after building. You're gonna win some rewards. And for that, we have some assignments for you guys for each workshop. So the first one, we have the assignments for DATs, how you can mint a data anchoring tokens. For this, we have the LazAI API. So what is the LazAI API? So LazAI API is the private inference you can do on your DATs. How? Stay tuned. You're gonna see it live in few minutes. I think we can start without further ado. Yep.
Yeah.
And sharing my screen. So you all can see this is the LazAI docs. You can check it through docs.lazai.network. I posted in the comments. You can check it out. So you can go over to the docs, and so this is basically to add your network. If you don't have added LazAI network, feel free to add your networks, and it will be required for you to get the faucet as well. I already have some. Yeah, I have some tokens, so I don't require to get it. So if you don't have, add your network first, and then use this Telegram bot as well as the faucet link to get your testnet tokens. The first thing would be to mint the DATs, as we have already minted DATs. In this tutorial, we're gonna solely cover how you can able to use LazAI API, and you can use both Python, NodeJS, and even Rust. For this tutorial, we gonna do Python, and this LazAI API requires two things. First, you have to mint your DATs, or at least use existingly minted DATs. So there has to be a DAT that is already minted and that have some data you wanna query on. And this is a really cool thing about DAT. You can't just see the whole data that is provided in within the DAT, because that's how LazAI differs. That's how the DATs still secures the privacy and still provides the facility to query over this data. So it's not like the DATs are publicly transparent data. it's still privacy secure, but you can able to do query over it. So you know what kind of data it is to the classes, so you can able to fetch and then use the DATs for querying purpose. So first we have to contribute the data, and either you mint your own DAT to do private inferences, or else you are using another person's DATs to use it. So whoever DAT is being used, you will pay a query fee that will be rewarded to the data contributor whoever minted that particular DAT. And coming to the second part, which is you need an inference server. So this inference server, either you have to do it on your own, that is like you can run it on your local machine, or you can use a remote inference. Either you set it up on your own, or you can set it up, or like you can use some others inference server. For this workshop we're gonna do a local inference, and we have actually done another workshop which showed how you can able to deploy a remote inference using Fala Cloud. So in order to set up a remote inference, you don't need a TEE service. So for that, we have an example for Fala, and it is the similar process for any TEE service available in the market too. So you can check it out, and we will post that link as well after this workshop. So we're gonna run a local inference server in this workshop, and it will be covered from true and true. The last part is you have a DAT. Either you contribute your data or you query through an existing data. Second step, you need an inference server. You either run it in inference server or use an existing inference server. For this workshop, we're gonna run our own server. Third step is actually do the inferencing. So you call the inference server to request a query on a private data, where this private data is held through DAT. So this DAT is holding a private data encrypted, and it will decrypt the data within the inference server and run a query and returns the response for the query without revealing the entire data or making the data which is contributed transparent to the public. In this way, it's a win for everyone, of course. So we already did the contribution of data in the last workshop. For this, we're gonna start with running the inference server, and proceeding to doing the request for the inference over different DETs. So through which we can able to do how we can able to chain the transactions as well as chain the querying for inferencing. Without further ado, let's start. For this workshop, we're gonna of course use Python, and you feel free to use Node.js or Rust. So first step we have to do is install the dependencies. So I'll share my other screen. Yep, just a minute. Yep, I open my terminal. Yeah, let's start. I close this, present my screen. Yep. So can everyone see my terminal?
Yes, but yeah, zoom in a
Cool.
little bit. One more time, I guess.
Sure. So I'll
Yeah, this
just
works. This works.
yeah,
Thanks.
change it directly to desktop. So I'm gonna create a new directory. It's called LazAI workshop, and I go inside the LazAI workshop. The first thing I have to do is open it up within a code editor. So I'm gonna use Cursor, which is my favorite code editor. You can use Visual Studio Code, Windsurf, or anything that you like. Not gonna do any prompting for today. Yeah, because this is all just to show you how exactly we can able to use the LazAI APIs. So let's go back to the documentation. So first step we have to do is activate the virtual environment in the Python. I activated it. And second step is installing the dependency. I'll first install Aleph, and then let's see what is this issue. It's coming up.
I'm sorry to cut you off there. Can you zoom in the screen as well?
Sure, sure, sure.
Yeah,
So
this would be
it is
nice.
because of this VNV source. Let me just delete this. Okay, this is new. Let me check what is this issue. Okay, so this is because of I'm trying to uh, create this like, so this is like basically whenever we do this in Mac we have some issues. So this is like externally managed environment, so whenever we install external packages, sometimes we get this issue. Let me check. So this is the issue with the Python tree. So what we can just try is, let's delete this env as well, the whole thing. And instead here, uh, yep. Oh, even the pith install have some issues, it seems. Okay, because like let's delete this as well. Over here, yeah, instead of Python tree, if we just go with Python, okay, here also we have some issues. Oh, okay, so let's use this to bypass. Let's, I think creating a virtual environment was not an issue. Yeah, and then let's install the dependencies. I'll just give double hyphen user flag to pip or set user is equal to true should do this. If you wish to install a Python application that isn't in Homebrew, it may be easiest to use pipex install. Hmm. So this is new. This is how I'm seeing it for
Yeah,
the
I
first
think
time.
that's like not available in the Homebrew, but we are just installing.
Yeah. Let me quickly
Mm.
like check through the docs again. I mean, I'm just using it. This morning it was not an issue. This is something I'm seeing it for the first time. Okay, I'll quickly swap you through something so that like we don't have to like debugging it over this workshop. So I'll just quickly show you something else that is like already working demo.
Till then, guys, after this workshop, we will drop the task 2 in
Yep.
forum. So if you have not joined a builder guild till now, feel free to go, and we have the steps like how you can join the builders guild in the one post posted in X that I'll share later in here in the live stream, so you can guys just whoever has not joined the builders guild can join quickly. And yeah, I'll give the rest information later. So let's still continue it.
Sure. So first thing is you have to install these dependencies. I hope like you won't um, met with the same dependency issues we faced, but I think like it's the issue with Brew. And once you install both dependencies of Llama, CPP, Python, and the other dependencies along with Aleph, you just have to do one more thing before get your hands dirty with the coding. First thing is have to expose the environmental variables. If you're gonna use OpenAI directly, the OpenAI API key, you just have to export your private key and the OpenAI API key. Else, if you want to use some other OpenAI compatible API keys like DeepSeek, Gemini, even Grok. I mean, Grok being really famous with devs. So especially for the extra tokens you can able to get, you can use any of them, and even Gemini is like very trending these days. So you can use them. All you have to do is get the API key, and base URL is also you can able to get it through the docs. You have to look for the base URL API key, and because for the OpenAI, the alert itself will get the base URL. You don't have to provide it. If you use any other OpenAI compatible APIs, you have to provide the base URL along with the private key and the API key, and the keywords will change. So don't confuse with the keywords for the environment variables. So don't export like the Gemini's key along with for the OpenAI API key variable, so that will mess up. So for the debugging it will be very difficult for you. The second thing is running the inference server. Here it also includes a external step. So there's a Google form you have to submit. So that Google form is actually within the LazAI API starter kit. If you go try it, I think in LazAI query, yeah. So I'll also share the that a form you have to submit. So this is the form. So you have to submit your like details and your wallet address and the server environments where you want to host your server. And this is same for like query data query, which is for the workshop that we have for the next week, as well as for the inference server. So it's either Falati, cloud, or local host or anything, because if it is local host, you have to provide the port, and for Falati as well, you have to show what is the hosted URL. And once it is done, you will get back to through the contact details you have provided, and once your wallet address is registered, you can able to use. So you need a wallet address. First you have to go through this, and I have already got my uh, inference server and query server registered. So I will just use that address, and so that is none other than this one. In the inference.py I will have a IDAV address. So this is my inference server registered wallet address, and we have all the code over here in the 0x LazAI in the same repo that we showed for the last time. If you look for the DETs or even the API starter kit, you can able to find it out. So in the DET minting and LazAI API demo, if you look at it, here's once the DET is minted, you can also see the inference.py. So this is a script for directly using the inference query, which is hosted somewhere else. For example, this particular address is hosted in a remote ATE using Fala Cloud, so that I can use it without my local inference server. But for this, we're gonna run our own server. First things first, you have to get it registered through this form. I will share the link in the StreamYard. Yep. So you first get it registered, and you can once you register and host it in Fala, you don't have to run it in your local again. So it will make your life easy. So going over to server.py, the script is really simple. So this is just for debugging. You don't even have to worry about it. It's just import the alert and alert inference, and there's a run module, and you have to pass the model. Model is basically which LLM model you wanna use, and the settlement is true. So all the queries will store on chain queries in a sense, and the settlement is all changed. So you pay a query fee, and then the DAT minter will get the reward. Otherwise, if you want to turn it false, it will just for like development purpose. And then the engine type is OpenAI. If you have a local LLM, you can also use it. It's not like you have to use the external LLM models. You can actually use your own like private LLMs, local LLMs if you have. And here is the twist. I have provided port. It is not a mandatory parameter. I intended it because in the form I submitted localhost 3000. Otherwise, it will fail. So for a particular address, I have to use this. And then where this address comes from, in order to run your inference.py, you have to export two variables. One is, of course, as it mentioned over here, your private key, and your OpenAI API key. So where this private key comes in, this private key is the key that will do the transaction for the inferencing. So in order to run your inference, you need it. And also, there's a one missed part. Is once you register through this form, you will get confirmation along with a private key. So that is a different private key. So that is like a RSA private key. That is for to or securely run your inference server, to also uniquely identify your inference server being registered in the LazAI IDA. So you will also get the RSA private key along with the confirmation of your address is being registered for the IDA inference server. Without further ado, let's first run the inference server. I think I have already running it. I'll just quickly go close it up, and I'll delete this terminal. So I'll first clear it up. I'm in a virtual environment. The first thing I have to do is python server.py. So this will run this server, and I have exposed the environment variables. That's why it is not throwing any error. Otherwise, it will throw error. And if I don't run this port, if I don't mention it externally over here, it will run it in 8080 by default, because the Python servers run in 8080. So you can change it however you want. So I just used the port 3000, and the server is running. So what's next? None other than straight away the inference. I'll open a new terminal. It is also within the virtual environment. Otherwise, we have to activate it. Go directly to the inference.py. So where do you get these script? So this is also in the docs itself. So this is the script I have just run. So this is the server.py. This is to run your inference server. And this is for using OpenAI. In case if you are using another model, let's say the DeepSeek all-one model especially, you just have to run this script instead. So this is basically the same, especially the model is changed over here, and you just have to expose few more environment variables, which is the LLM API key and base URL. So if the model is different, and it will look for a particular environment variable such as the LLM API key and then LLM base URL, so you can able to do a query. This is done. So we have successfully running the query server, and it is running in 3000. The next step is again request inference via LazAI client. So this is all we have over here, the same code. So first thing is import alith, and the second line is import alith and LazAI client. So LazAI client is basically uh, the the blockchain client to run the transaction. So how we run the transaction, because we have exposed the private key in this environment variables, so we are not actually like signing transaction to user interface. Here we have a LazAI IDA address. This address I have registered through that form, and after registering, I have received a RSA private key. So without it, I would not be able to using this. Have the client instance, and this is the deposit amount. So this deposit amount is a small amount in way. This is used for querying purpose. So this inference server, so let's say somebody is running an inference server, so why would even somebody run an inference server? So this is an economical model in which somebody can able to run an inference server who have like a TE environment, and a high computing environment, who can set up TE on their local system and then provide it as a service. And this deposit amount uh, would be divided between the DATs, as well as for it's basically rewards for running the inference server, and as well as rewards for minting your data as DAT. So the data is available but still secured the privacy, so we can able to do an inference on it. First things first, we check the client address. So once we run the script, we can able to see it. And if the client dot get address function can able to figure this out, whether this address exists or not, which means this particular address is already there, so it doesn't need to do deposit again, because like existing user who have already deposited. If the get user function returns null, it will go to the exception block. So this is a try block and then except block. In this, it will throw this error, throw this print statement, and it run two functions. So first function is add user and then deposit. So add user is like registration, and once this registration is done, you can able to query through this particular inference server. So this add user function is tied to a particular IDAV address. So this IDAV address is basically tied to inference server. It's either running locally or running in a remote Fala cloud or like TE cloud. So we have one function is cleared out, and the second function is the deposit function. So this deposit function is like, you have a registration fee to go in, but for every query you have to do um, a deposit for running your queries. And this deposit is like a advance you pay. So the add user is like, add user and deposit functions are similar. Here the add user is to add your address, that is like a whitelisting yourself within an inference server, so you are allowed to do inference within that server. And this deposit is like, it's like paying a subscription. So add user is just one time, you don't need to do it again and again, it's just one time. You cannot able to like redo it again at all. But this deposit is more like a subscription or like a prepaid plan. So you deposit some amount, and until that is being reduced, still you can able to do the inference. And here comes the deposit inference function. So this is unique for each transaction. So whenever you do an inference, you pay a deposit inference fee. So you pay, and you do it's like more like a service fee or a query fee for inference. So this is like the exception. If all of them are fails or something happens, it will throw the exception. And the file id 10 is something I have contributed some time ago. So this is regarding a particular epic fictional content. So this like a fictional content, so that we can able to query and then uh, query through this using this inference server. The first line we have here, the URL. So what is this URL is? This is the inference node. The address that we have here is basically linked to our inference server running somewhere. For us, it is running in the local. So we get it and then we slice it to the first position. And basically, this is like the second position, but in computer science, we say zeros and one, we count in zeros and one. So it is the first, is the actually technically the second position that will return the URL. So this URL is the URL of the inference server running somewhere local or remote. And with this, we get the inference account. So we check whether the address is registered. It's our querying address, and this is the IDAV address. If yes, we can able to go ahead and then run this agent client. So we are creating an agent instance, and this model should match up. So the model that our inference server is running and the model that the inference requesting for should be matched. Otherwise, let's say we have an inference server running in Grok and we are requesting from Gemini, it won't match. So it will look for a Gemini instead, but there's like no Gemini's URL. So it will mess up. So make sure the inference server's model and the request model is the same. And we have the base URL. As I'm using the OpenAI API, I don't have to provide anything. But here, where this base URL comes from is this URL. This is the URL exactly where it fetches the inference node. And because we provided the API within the inference node itself, and the extra header basically have the IDAV address and file ID. This is the preamble. So anyone who used Alert agent before, or this is the first time you are seeing it, you can actually build any agent using Alert. It doesn't even have to like do everything with DAT. So it's a open um, agent building framework. So in order for this framework to understand this DATs and LazAI, we have to provide this extra headers. So that's why we use this function get request headers, and we send the LazAI IDA address and file ID. So it will look for the file ID and fetches it, and because it is encrypted, it will decrypt the data and run a query in a secure way, so that the data won't be get transparent and exposed to the public. So this is the agent instance, and we call the instance over here. So in this instance, this is the prompt that we are sending. What is it, and what's the answer? This prompt is really basic. Let's make it interesting.
Dude, can you
Interpret
zoom,
this
zoom in a
data.
bit?
Sorry.
Can you zoom in a bit?
Oh,
Yep, that's right.
I almost explained the most part of it.
That's okay. I
Okay.
also just realized that. Okay.
Yeah, I'm sorry, guys. Next time, just start spamming in the comments, so we will get. And like
Yeah.
usually, give more time for this to set up everything, but this time we got ourselves within this. So let us know if it is not very visible to you. Start spamming in the comments, start DMing us, let the notification goes crazy. So we have already running the inference server. We can just run the script to request inference on a particular DAT file, which is the file 10, and we gonna pass the prompt, interpret this data emotionally. Just gonna send it and provide the summary of the data. Okay, so this is, I'm gonna run this script, Python inference.py. So we have the wallet address. So this is the same address I'm using in my local system as well. And there's a few interesting things. User already exists. So this is printed from this line 15, which means I have already deposited. So this except block will not be executed because I have used this already. If you are using for the first time, for you, this all these functions will be executed for you, the three functions. If even like one of them fails, it will go to the except part, and then uh, like the rest of the code won't be executed. So that's why it is wrapped like this. This is basically example of how you can do the inference query, so you can able to build things on top of this. And we have the URL. So this is the interesting part, as I said. So this will print the URL of the inference server that is hosted either locally or in remote TE environment. For us, it is local, and that is what I have registered to the form that I shared. So this is the HTTP, the localhost 3000. This is none other than this one. You can also see what happened over here. First things first, the server is running without any issues. We have a request, and this request is for the file ID 10, and it successfully proceeded the request. So this is for basically fetching the file, and where this file is stored in a Fala cloud, sorry, in a Pinata cloud. So this is an IPFS, and there's a hash for it as well. And this is the revenue share that it doesn't have any, and the data queried with the file id 10 because we included the file id 10 over here. And what happens here is, so this is where the inference happens. So it have a post request to OpenAI, and here we can see that v1 slash chat slash completions. This is anyone used OpenAI API, you can see this is the API used to query, and we can see we got a successful response for it as well, the 200, and it is being sent back to the users, and where we have requested, we can see the 200 for this as well. And let's go back and check the response. We can see this is the prompt that we sent and how it is being interpreted over here, and we have the content, which is the response that we need. So this is a data evokes a sense of excitement and intrigue. And yes, of course guys, so this is all the data that is available in the internet for this Naruto series. So think about it. So this is a really powerful tool. So I have provided a exemplary large data through the LazAI DAT, and you can able to precisely query through it within a seconds, within the matter of seconds. This is how powerful you can able to execute with the DATs and LazAI API. With this, you can able to do the inference all within matter of seconds. It provided how the prompt being sent. So our request is interpret this data emotionally and provide the summary, and you can see it highlights the different emotions like overcoming the cycle of hatred, or highlighted emphasizes the value of the data set for AI training and world building and narrative structures. So similarly, you can able to first contribute your data through DAT. If you missed it, you can able to check out our previous workshop. We will also post it under the comment or description in the YouTube. You can check it out, and maybe in the I button as well. You can able to check it out. So contribute your data through DAT, and with that, which is basically contributed, it's not like transparent, it's not like you are publishing it for public usage. It's like privately secure, and for every time your data is being queried through LLM, you will, so this is how it is being queried. You will get a fee for it. So it's like a reward for it because you contributed data, your data is being used. And even if it is used in a chain manner, if your data is being used by another deities, and another deity is using another deity, even through the chain, you can able to backtrack and provide rewards to the deserving provider, whoever minted the data and whoever contributed the data. So we can able to backtrack and reward for who deserves it. And the actual contributor will able to be get rewarded. So we can able to avoid the copying as well. So it's all done through transparency and through the power of blockchain, of course. So that's how like LazAI differs. You can able to do the inference through this, the similar pattern for both Rust as well as for Node.js. So all comes to the same thing. You'll check first the get user function. If you're already registered, you can go ahead and then do the inference account and directly call the agent. Else you have to add yourself deposit and do the deposit inference, so that you can able to do able to run the query. And so this is how you can able to run a private inference on LazAI using the DETs. Do we have any questions?
Not in the comment section. I just see a comment in like, how do we get whitelisted? So I think that's when you.
Yeah, so you I'll post this again. Oh, okay, you already posted it. Okay, so if you use this, use the Google Doc I just posted in the comment, you can able to first provide your wallet address and then the URL in which you want it to be registered, whether it's localhost or Falati. And if you're wondering how on earth I'm gonna deploy it on Falati, don't worry, we have a video for that as well. So you can find those all in the comment and then description. So, and also in the follow-up post in the Twitter after this workshop, we will also include those, so you can able to find them easily. And if you can't find it at all, reach out to us in the Twitter as well as in Telegram. So you can find me in Twitter 0x2, and we have Nidhi as well. So you can reach out to either of us, so we can able to help you and make this learning fun.
Yep. Guys, do we have more questions? Feel free to, just, bombard our comment box with questions.
Yeah, we would love to answer this question.
Yeah, because you're gonna do the task too, and like we don't know, like, if it's gonna be super easy or little bit intermediate level, or it gonna, maybe little hard. So depending, if you have any questions, because you're gonna perform the task too, so feel free to drop any comment, any questions, feedback, anything. And if you're like more questions, we are always available on the Discord, and which is like another part, like, when you join or when you submit at your task, you had to just join the Builder Guilds and join the Discord. And on the forum, on the Builder Guilds forum, we're gonna share the task too, and there will be the link that how you're gonna submit your task to. So
Yep.
keep eye on our socials that we're gonna share soon. That this is our task too, and this is the forum link that you can join and perform your task to and submit and take a chance to win some prize.
Yeah, and it's not still too late to complete the task one as well. So if you feel
Yeah,
like I missed task two, sorry, I missed the task one, should I do the task two? Could I able to win some rewards? Of course you can. The time is still
yeah,
there. So go ahead, complete the task, and if you find any difficulties with anything, you know who you should reach out to. So
yep.
all right. Cool. So if we don't have any questions for this workshop, I think we can wrap this up. And for any questions, reach out to us. We will be there to help you out, guys.
Yeah, guys. Yeah. Till then, bye, guys. Take care.
Bye
Bye
bye.
bye. Is it?